And this logo is just what I use for my company and presentation. So I find it funny. But so we'll talk about Spark, right? And this is the presentation I gave several months ago, and I'm kind of repeating that. What you're seeing here, Nilima, I don't know if you have seen this before, is it's a notebook. I'm showing it's not PPT or anything. You can see it's running in a browser, and I'm running on Databricks. Databricks is a cloud company, and Databricks people are the one who came up with Spark. And once they came up with Spark, they gave it to open source, and then they created a company called Databricks, which had a cloud offering. So that's what I'm using. So what I do is I just use the notebook they have as a presentation tool. So I can mix. You will see later on I can mix code and and, and the pictures all in one notebook, and you'll learn more about the notebook later on as we go along. So have you have you had any exposure with Zeppelin, Nilima? You guys have heard about Zeppelin notebooks? Shrikant?
No.
Okay, so
No, unfortunately.
so notebooks are just a quick thing on notebooks are fantastic. I love them. What it is, you can consider. So, Srikant, are you a Java programmer? What kind of programming you do?
Uh, Actually, a web SAP
SAP.
application development.
Okay. So
Yeah.
SAP has the NetWeaver, some IDE, right? Some tool, right, where you write your code,
Yeah.
right? What do you call
So
that?
yeah, NetWeaver web workbench is there. So we
Right?
have a web editor. So that's where we write our code.
Right. And if you're a Java programmer, you will do something in Eclipse, correct?
Yeah.
If you're a .NET, you'll do Visual Studio. So this notebook, you can see that as an IDE, and it's lightweight. You can see it's running in a browser, and you can I can add cell above, and I can start typing, and I can sorry, I typed too fast. That made no sense because I'm talking while I'm typing. So when you get a chance, so let's not. I will just stop talking about notebooks anymore. Notebooks are great. That the code you write for Hadoop and Spark, you can write in Notebook and you can save it, and you can execute it as a REPL. Have you heard the term REPL?
No.
Okay, so REPL is like command prompt. And like if you on the DOS prompt, right? Windows
Okay.
command prompt. You type something, something happens, right? Right underneath that. Or Unix shell prompt. You type something, something happens. That's what a REPL is. Uh, read, evaluate, print, loop, right? That's what it is. That you type something and then you hit OK and then something happens. So these notebooks are all REPL tool. And if you're a R, statistical tool, R or Python developer, those guys are very, very familiar with the REPL concept. Python, they use something called IPython notebook, and R has its own notebook. And it's very easy that it's on in a browser, and so you don't have to install anything. And you can create these notebooks for whatever language you like. So if you can see here, Srikant, I don't know if you can see it here, that it is training section 5, and this is called the Scala is a language, and this is a Scala notebook. I could have as well created notebooks for for whatever language I need. I can create an R file, whatever, and it's like it creates a blank page, uh, and you just start writing R code right here, right? And so it's kind of like IDE. And as I said, I'm a big fan. I love that. So what I do my presentation and code all in once, so it's easier for people to understand what's happening. All right, so enough about notebooks. What was wrong with Hadoop? Why did we have to ditch Hadoop? Why did we have to go to Spark? Well, what were the good points about Hadoop, and what were not so good points about Hadoop? सोचिए. So let me give you a hint. I mean, Hadoop was all batch. Okay,
Mhm.
Hadoop
Mhm.
was all batch. Massive,
Okay.
massive amount of data crunching in a batch mode. You know,
Mhm.
so if you remember, yeah, the other day we talked about the two components of Hadoop are the HDFS, right, the file storage, Hadoop distributed file system, and the programming model, or the programming paradigm of the MapReduce programming paradigm, correct? So those were the two key elements of a Hadoop distribution. When I say Hadoop distribution, Hadoop is open source, right, obviously. You can go to apache.org/Hadoop, download a copy of the binaries, and create your own standalone Hadoop cluster on your laptop,
Mhm.
correct? So, but many other companies, and I'm sure you're familiar with those, many other companies such as Hortonworks, Cloudera, MapR, IBM, Google, they have taken that open source code in Hadoop and they have added more management tools, added more nice enterprise features on it, and they sell
Mhm.
those, sell the licenses for it. Hortonworks doesn't. Hortonworks sells support and services. MapR as a distribution, they've added a lot of new things to it, so they sell the license. But the core is still free and open source, kind of like the Linux model, right? So, so that, as I said, the Hadoop had two major components: Hadoop distribution, HDFS, and MapReduce. What Hadoop was, so Hadoop became very successful. I mean, you know, because the two or three things were that you can crunch a lot of data using regular hardware. That was its main thing. Regular hardware, you don't need very expensive $1 million, or as Dr. Srini was saying on the previous lectures, you don't need the super cray or super mini computers to crunch this much data, right? You can have a cluster of standard, very ordinary commodity type servers, and you can finish these jobs, right? So Hadoop became
Mhm.
very popular. Became so it was very cheap, and the 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 source itself. The source code was free, open source. So all you need to do is just string together a few servers, put Hadoop on it, and designate one machine as name node, and start pumping data through it and watch it crunch. And you have to write your MapReduce code. So it became very popular. The when it Because of how popular it became, people
Mhm.
wanted to do more with it,
Mhm.
right? And people wanted to do more with it. Like, hey, this is great. Why can't we? Why does it only have to have batch? Why can't I query it? Just like you query a database. You know,
Mhm.
why can't you just write a query language and get results back? Why can't you attach it, tag it to a BI tool, right? Why can't you tag it to Tableau or something, and you're going through this huge data set, and you can slice and dice, and you know, and you would expect the results to come back, very quickly within five, less than 5 seconds. And if it's not, then people will not use that tool, right? People will say it's very slow. But Hadoop was never meant to do any of those things, right? Hadoop was
Actually, the data is in text files, right, or comma separated files or something
sure,
like that, right?
sure, sure. Data
So
is
the select will not work on those files, right? So
which will
I
not
mean,
work.
we need to upload it into the database. So database structures need to be created, tables need to be created, and everything. Then only
And
select will.
that's one way. I mean, to query a huge data set, SQL is just one way to do it, right? Hadoop, you can query a Hadoop set, just not using SQL, right? You can use Pig, you can use Java, and there are filters and selects and group bys, and you don't have necessarily have to have a database per se. And you'll see when I talk more about Spark SQL how that works out. Hadoop, you could Hadoop was so basically, Hadoop was a victim of its own success. That it was very good at crunching large amount of data using
Mm-hmm.
cheap machines,
Okay.
right? And because of it was using cheap machines. Remember the other day we talked about it. That fault tolerance and was a very important thing. If there are 50 machines and one machine fails, then what happens with the data it was crunching, right? So that was not acceptable. So if you remember what we talked about, the anytime a file is written into HDFS, it makes three
Mm-hmm.
copies. Remember the three copy thing, right? One is primary
Yeah.
and the replication factor of 2. So if the first machine fails, one of the other two machines can take over, right? The data is never lost.
Yeah.
Because the fundamental understanding was the hard disks fail. Uh, it's not like your huge SAP ERP installation or my Teradata thing. Those are specialized hardware, very high reliability, and they don't fail that much, right? Or you can hot swap the disk and everything. But those are very expensive machines. We are talking about regular, regular Linux servers. They fail. So then so reliability was a big thing, and that's why the triple replication came. And as you're going through steps, suppose, and I was giving you the election night example, if had 15 steps to count votes, every time a step is completed, because
Mm-hmm.
Hadoop is generously using disk, so it will, because it was fearful that a machine could in the cluster could fail. So anytime it completes one step, it will write that intermediate result back to disk.
Mm-hmm.
Both, this is a very key thing to understand the negatives of Hadoop. Every time it will complete the intermediate step, just kind of like we do in query, if you do when we used to use a lot of SQL, that you will write uh, a huge query, and then you wanted to save that into a temp table, then use another query on top of the temp table and create another result set and so on and so forth, right? If you have you ever had experience doing something like that, Shrikant?
Uh, Actually, no. Can you just tell me why it is a issue actually here? Because it has to process and write the results, right?
Right. So now if you remember, disk access versus memory access. Disk access is 1,000 times slower or even more, right? So every time the next step wants to continue, it has to read that data written to disk from the previous step. And that is slow. That is slow. Now, as if you have a large job and 20 steps, every step that the results are written to disk, and the next step is reading it back and reading it back. And so it's a back and forth, a lot of data being read off disk, and all that was makes Hadoop very slow, right? But that was part of the design. It's not that Hadoop is slow. That's how it was designed to be fault tolerant. That any time, if you are done with 5 steps and before the sixth step one machine fails, the newer machine that comes online could start where you left off, right after the fifth step. Neelam, am I saying the right things?
Yeah, yeah.
Right. So so uh, so that's uh,
Yes,
so that
perfect,
was
Sudhanshu. I mean, definitely you're getting better experience learning all this.
ah so so then that was not acceptable. People wanted faster faster performance. So then people started going into the memory thing, and memory started becoming cheap. And I'm talking about, 2000 late, 2010. About memory became very cheap, almost that the previous constraint we had, the disk was cheap and memory was expensive. That was not the case. Memory was getting cheap too. And as you know, since you're an SAP programmer, and I'm sure do you have any experience with HANA, Shrikant?
Yeah,
Right. So
yeah. So
HANA,
it's all like memory processing. Yeah.
bilkul. So then, so HANA, these guys, so one team came up with Spark, right? And there are other in memory uh, implementation of big data too. But these guys came up with Spark, and Spark was that, hey, I wouldn't that instead of map reduce, we will process data differently, and I'll go through that, but we will not write the intermediate results onto disk. And these are very HANA-ish, if you will, concepts. There is no intermediate writes back to the disk. Everything is in memory, and as memory is being as process, as subsequent steps in a big job are being employed, it will just pick from the data is already hung in memory, so it's very quick. So it doesn't have to go back to the disk. Again. So that is the very high level. So now if you see here, so what is Spark then? So Spark, you'll see, uh, you'll the wrong. Let me tell you the wrong answers. So the wrong answers are that Spark is a replacement for Hadoop. Wrong answer, right? Spark, and why is that a wrong answer? Uh, because Spark is meant to work with Hadoop in parallel, right? And I'll repeat, the Hadoop had two major components, the HDFS and MapReduce. So the MapReduce portion of Hadoop, Spark is replacing that. But Spark in itself, and we will go through that, in itself doesn't have any storage, so it does need to store the data, pick up the data from somewhere, and store the results back to hard drive, hard disk. So it needs, if it's not HDFS, it needs some disk storage, right? It could be Amazon S3, it could be a Cassandra database, it could be MongoDB, but it needs a storage system. And so the wrong answer is that is replacing Hadoop. Okay, and you'll hear that a lot. As you see, I don't know if you guys can see my screen, correct?
Yeah.
Yeah, so the Spark is a major improvement over Hadoop's MapReduce paradigm because of the whole intermediate writing to disk thing, right? I was telling you about, and I'll go more in details into it. So Spark, they created, uh, it's more like a, in terms of SAP, if you want to see it, it's a JVM, it's a platform where which runs inside a JVM. It runs inside a Java virtual machine. Uh, that way you can see it just like similar to a .NET type CLI, what they have .NET, or in Java they have the what do you call the name of the J2EE type, the main engine that on top of which has the core components, and on top of which you can have languages and you can have language bindings. You can see Spark engine as something similar to that. And so Spark is a distributed programming platform. And what it is, the difference with, you can say, okay, C++, how is it different from C++? How is it different from Java, right? Uh, what it is that now, instead of working on data on one machine, on one server like you would do in your standard Java program, Spark is doing the same, right? The programs written in Spark could run on a distributed, in a parallel way on a distributed cluster. So you can imagine if just like in HANA, if you're breaking the job into multiple machines and you're crunching data on each machine and then you're coordinating the results back, there has to be a lot of coordination, right? For the to get the results back and to tell the the nodes in the worker nodes in the cluster what to do next and what are their tasks when they complete the task. If the machine goes down, all those coordination someone has to do, right? So,
Yeah.
so, so that is what Spark is. It's a general purpose programming platform. You can write Spark programs in Spark in many languages. One of the most common you will hear is Scala, and not sure if you've heard of Scala. Scala is what they call functional language, functional. And I'm not a Java programmer, but I believe Java 8 has some of the functional programming elements they have added with the Lambda functions, etc. So Scala is since Spark was written in Scala, and so it makes sense to write all the API. The APIs are in different languages, right? The APIs are in Scala, Java, Python, SQL. But I find it useful to use the Scala language bindings. It's exactly the same thing. It doesn't matter. Just like in .NET, and I did .NET for a very long time. It doesn't matter if you write C# or VB.NET or whatever. It compiles to the same bytecode, and language is just whatever you're familiar with. It's exactly the same. At the end, the bytecode it creates is exactly the same. Right, Nilima? That's correct, right? So the language
Yes.
is yeah. So language is irrelevant. Uh, APIs are the Spark APIs for, binding for every one of those things. A lot of people are Python programmers who come to big data, and Python library API is very rich. Uh, but what I have seen and what I've experienced, the Scala ones are more native because, as I said, Spark itself was written in Scala. Okay.
Can you go to this Databricks which you showed?
Uh,
So, I mean, how do you use this? Because you were choosing the programming language, right? R or Python.
yeah,
You have Python also, right?
yeah. You see that? So you can write Python, SQL, Scala, Java, just whatever. Yep. So,
So
and
you have all the infrastructure which can run our programs, is it? In the
very
backend?
cool. So let me give you a quick thing. So if you go to databricks.com, right, uh, and you can sign up for account and everything, and and so then you get this IDE, and as you can see, it's running in a browser, right? And what happens then? I can go in there and I can create a cluster. Okay, uh, uh, so I can say this is kind of, if you haven't seen this, this is fascinating stuff. Uh, like how easy they have made it. So what I want to do, I want to create a cluster of whatever, uh, just like that, right? 100 machines. And what this will do, and you can see the 3,000, what is that, terabyte? And a 3 terabyte memory and
Yeah.
400 cores. And I can just confirm it and I can create a big cluster. So now your question should be, where is the cluster being created? ठीक है? Right? You must be thinking. ठीक है? So it's all
Yeah.
cloud. So what it does, it's a layer on top of Amazon Web Services. So this Databricks, if I say create 100 machines, it will go there to AWS, and I have an account over there, and these two accounts are linked, and it will go there and create in 10, 15 minutes, it will create me a cluster of 100 machines with this much whatever, and then hand me the the connection, basically connection string to the cluster, and then I can use that connection string and start writing my app in Spark, in Scala or Python, whatever, and run on that cluster. How cool is that?
Where do you upload data? Like,
Ah, so those questions are good, right? So now, uh, but in 5 minutes, 10 minutes, I can create a 100-unit cluster. How do you upload data, right? So it's a very, very easy ways to do that. You can create okay, so it's saying you have to create a cluster first. But you can import data and whatever data you have in anywhere, either on your machine or on cloud somewhere. It just doesn't matter. And I have tons of examples where I do just that in my training sessions. People just like sorry, that you just want me to show the whole big what do you call life cycle, that I load a file and write some code in Spark, and then run it on the cluster I create, and then I get the results back. That's a very common thing I do in the training, right? So just assume for a second all that is built in. It's trivial to load data from anywhere, and whatever kind of data you have, right? And and if you want to, so so let me stop there. So do you want to learn more about Spark, the architecture?